All right, so refer to exercise 35, which is what I have here. Suppose we select independent simple random samples of 25 men aged 20 to 34 and 36 boys aged 14 and calculate the sample mean heights x bar m and x bar b. Describe the shape, center, and spread of the sampling distribution of x bar m minus x bar b. Okay, so what we have here is, remember, we had from the previous problem that m is normally distributed. That's what this is saying, right? With a mean of 188 and standard deviation of 41. And what was it? B was normal with a mean of 170 and a standard deviation of 30. So remember, this implies that x bar m, right, is approximately normal, where the means are the same, right? So this will be the mean of m, which is the same thing here. And the standard deviation for this sample mean, right, this random variable of the sample mean, is the standard deviation of m over the square root of n, right? And then same thing here, x bar of b is approximately normal with the mean of b and the standard deviation of b over the square root of n. All right, so let's go ahead and calculate these guys here, right? So we want to find the standard deviation of x bar m, which is the standard deviation of m over the square root of n. Okay, so remember, the standard deviation of m was 41 over the square root, and the number in the sample size is 25, right? So 25. And this is the same thing as 41 over 5, which turns to 8.2. And the standard deviation of x bar b is equal to the standard deviation of b over the square root of n, which the standard deviation of b was 30 over the square root of, what was this? 36 boys. 36. All right, let me do a better job with that 0, right? So 30. So this is 30 over 6, which turns into 5. Okay, so this means that my x bar m is normal with the mean of 188 and standard deviation of 8.2, and x bar b is approximately normal with a mean of 170 and a standard deviation of 5. All right, so now I have my random variable for the sample mean of the men and the sample mean of the boys, right? So now they want me to find, so this implies that they want me to find x bar m minus x bar of b. This means this follows a normal where the mean is going to be the mean of x bar m minus x bar b, and the standard deviation is going to be x bar m minus x bar b, right? Okay, so now let's go ahead and find these guys, right? So we know the mu of x bar m minus x bar b is equal to, so this is the same thing as the expected value of x bar m minus x bar b, which is the same thing as the expected value of x bar m minus the expected value of x bar b, which is the 188 minus 170, which is equal to 18. All right, so now let's find that standard deviation of x bar m minus x bar b, which is, well, let's find the variance first, right? So the variance, this is equal to the variance of x bar m minus x bar b. And we know if the original ones, if M and B were independent, right? That means their sample means will be independent as well. Okay, so this is independent. So this means that this is equal to the variance of x bar M plus the variance of x bar B. And then this is equal to, so the variance of x bar M is standard deviation of M squared plus standard deviation of x bar M, right? X bar M, standard deviation of x bar B squared. And then we had that here. That's 8.2 squared plus 5 squared, right? And then this will be equal to, so if you do the math there, that is 92.24. All right, so we have the variance, but we want that standard deviation, right? So this means that the standard deviation of x bar M minus x bar B is equal to the square root of the variance, right? X bar M minus x bar B squared, which is equal to the square root of 92.24, which gives us 9.6. So we have our distribution of x bar M minus x bar B is approximately normal with a mean of 18 and a standard deviation of 9.6. Let's do part B. So find the probability of getting a difference in sample means x bar M minus x bar B that's less than 0 milligrams per deciliter, right? So for part B, we want to find the probability that x bar M minus x bar B is less than 0, right? Well, we know x bar M minus x bar B is approximately normal, so we can standardize this. So that'll be 0 minus 18 over 9.6, which if we do the math here, that'll be the probability that Z is less than negative 1.88. Let me go to my table. So negative 1.88 gives me the 0.0301, right? So 0.0301, 0.0301, which is about 3.01%, right? So part C is, should we be surprised if the sample mean cholesterol level for the 14-year-old boys exceeds the sample mean cholesterol level for the men? Yeah, because the probability that happening is only 3%, right? So part C is yes, the likelihood that the sample mean of the boys is greater than the sample mean of the men is only 3.01%. So yes, it would be not likely that the mean of the boys would exceed the mean of the men.